Hi everyone, my name is Jakub Staroń. This is the next episode of MedChem Essentials, and today we'll be talking about the clearance essentials. Today's presentation is part of the second large block of our course, which is related to the half-life. Today, first we'll say a few words about bioavailability, as it is important for the understanding of the following terms and information. Next, we'll see some example calculation of clearance of some example drug. So the bioavailability, it represents the fraction of the drug that was absorbed from the digestive system into the bloodstream. Despite many oral drugs being well absorbed, their bioavailability is almost never 100%. And this is because those drugs are being metabolized by the liver via the so-called first-pass effect. The subject of today's presentation of our calculations will be the Benadryl diphenhydramine, which is quite well-known antihistamine drug. The total clearance for Benadryl is 6.2 milliliters per minute per kilogram. Urinary excretion is below 2%, and the bioavailability is 72%. With such low urinary excretion, we can safely approximate urinary excretion of Benadryl to be zero. And for the 70 kilo patient, the total clearance will be 430 milliliters per minute. If we take in this approximation into mind, we can say that the hepatic clearance will equal also 430 milliliters per minute. And we can take this information literally or more realistically. And via these two interpretations, the literal one and the realistic, we'll calculate the clearance of Benadryl. All of this discussion will focus on capturing the 1 minute of blood flow through the liver. Let's see the literal interpretation of the hepatic clearance of Benadryl. So the typical plasma concentration for diphenhydramine is 50 nanograms per milliliter. Having the, as you may remember, the blood flow, liver blood flow of 1.5 liter per minute, and having this initial concentration of 50 nanograms per milliliter. If we have the hepatic clearance of 430 milliliters per minute, it will mean literally that 430 milliliters of the hypothetical blood that leaves the liver is completely cleared out of the drug, out of the active substance. And so around 1 liter of the blood will have the concentration of 50 nanograms per milliliter. We need to take here the correction factor, as this is the plasma concentration, and this is the blood, and not the plasma. And around 54% of the volume of the whole blood is the plasma. So for all the calculations, we need to apply this correction factor. To calculate the mass of diphenhydramine that enters the liver, we take the hepatic blood flow, the concentration, and the correction factor. This simple maths gives us this number, 40,500 nanograms of Benadryl that enters the liver each minute. The mass of diphenhydramine that leaves the liver will be calculated exactly the same way. So we have the volume of blood, which is this 1 liter, divided by the concentration and the correction factor, and we have almost 29,000 nanograms of mass of the Benadryl that relieves the liver. Now let's go to realistic interpretation, because it's not like that somehow the liver separates pure blood and the blood with the compound like this. It just decreases the concentration, not separates pure blood and blood with the drug. So, and for the purpose of this calculation, we need to take the bioavailability, which, as you may remember, was 72%, which means from the equation introduced on the previous presentation, we can calculate the hepatic extraction ratio, which is 100% minus 72, which gives us 0.28, the hepatic extraction ratio. And from the definition of the extraction ratio, we can calculate the concentration of Benadryl that is in the plasma that leaves the liver. And from taking this simple math, we obtain the number of 36 nanograms per milliliter. This is the concentration of the drug in the blood that leaves the liver. Using the same equations as on the previous slide, we calculate the mass of diphenhydramine that enters the liver and the mass of diphenhydramine that leaves the liver. Through these equations, from this calculation, we have a number of 29,160 nanograms. Those numbers are very comparable. So via literal interpretation, we got, of course, both of them, we got the same mass of diphenhydramine entering the liver. However, the mass of diphenhydramine exiting the liver is slightly different, but approximated to more or less the same value. Through this, we exemplified two methods to consider clearance, one literal and the other is realistic. However, the conclusion is always, is in both cases the same. High clearance, meaning the drug leaves the system fast, and low clearance means the drug leaves the system slow. Thank you very much for your attention, and that's all for today. Thank you very much. See you next time.